Hello everyone, this is Fredrick Mlenga. Okay, so upon finishing the revision on electricity, I also thought it can be befitting for us to have a tutorial video as grade 9s so that maybe in your comfort zone when you are at home, you can go through this video so that it reminds you some of the key concept of electricity at your level. So I'm going to share this video on your Google Classroom. Yes, for all grade 9 of 2020-25. Try by all means to watch this video so that you revise properly, or it reminds you some of the key concepts. Okay, so as you can see on the board, I have tried to extract few questions from exam past papers so that we can go through together. Okay, feel free when you want to try to pause a video and do it on your own. Okay, so let's get started. Okay, so certain things or terminologies that you should be aware of under this topic at your level is that we'll ask you to define terminology in electricity. So you need to know what is a voltage is. You need also to know what current is. You need also to know what resistance is, including their SI units. Okay, so I'll begin try to refresh your mind on these terms. So we did learn that current, this is the flow of charge in the conducting wire, and current is measured in amps. It is measured in ampere. Okay, in ampere. So from this word we get a capital letter. So every time you calculate current, you put capital letter A. Don't forget, I know some of you when you are fast you forget to put the SI unit, but it's very much important in the aspect of science and physics. We really need these two, because we can't know what you've calculated if you will be mangoes or lemons. So for you to indicate the correct SI unit of physical quantity, you need to put the SI unit correctly. So current is measured in ampere, and the instrument that we use to measure current, we call it ammeter. So in the circuit, ammeter is represented as this, something that looks like this, represent what? An ammeter, which is the instrument we use to measure current. As you could see in the first question, this one, so this one represents what? An ammeter. Okay, then the second terminology that we want to look at is voltage. So voltage is defined as voltage is defined as the energy supplied to each coulomb of a charge within it. So we have two types of voltage. I don't want you to make mistakes in the exam. The voltage that is supplied by the battery, for example, what you are seeing here on this diagram, we have 6 volts. This voltage is called EMF, or electromotive force, abbreviated as EMF. It is voltage, but to make it different from other voltages, we call it electromotive force. Okay, then the voltage that is used by the component connected in the circuit, like this one, like that one, it is called a potential difference. So we call it potential difference, or abbreviated as PD. So now what is this voltage? How can we define potential difference? So it is defined as the energy converted per unit charge passing through a component. So let me breathe life to that definition so that you get it. So if we have a wire connected, we have a battery just right here, connected just right here, okay, and we've connected our wire there to a bulb, just like that. This is our negative, this is our positive. Okay, so we have learned that the voltage supplied by the power source, in this case our battery, is called EMF. So the amount of EMF the battery supplied to each charge passing through here. So that we are having charges that are here not moving, but if this supplies voltage to this, they'll start moving across the conducting wire. Okay, now when they reach here, this charge reaches here, that EMF which was supplied to this charge will be converted, the energy carried will be converted into what? Into light energy. So this amount of energy converted per unit charge passing through a component, at this particular component, which is a light bulb that we're having, is what we are referring to what? As PD. So both EMF and PD, they are voltage, and they have the same SI unit, which is volts. We measure them in volts. So you have to take note of those differences. All right. So that's about voltage. Then we have another term which we call resistance. Okay. So as the charge start passing here, it moving in this direction, the charge is being pushed and this switch is on. As the charge passing through this conducting wire, there will be a force opposing them oppositely as they are moving through this wire. So that opposition to the flow of current is what we call resistance. So resistance is the opposition to the flow of charge or electron passing through the conducting wire. And the instrument that we use to measure resistance, we call them resistors. Okay, so we call them resistors, and we use these symbols to represent resistors in the circuit. So anytime you are looking at the circuit, you see this, it means resistor. The other way we can write them, we write them like this. This is also a resistor, it represents resistor. But there is also another instrument that can measure changing resistor, or you can able to change the resistance, so that in the circuit diagrams it is represented with a normal resistor symbol, but you put an arrow there. So every time you are seeing an arrow crossing through the resistor, that instrument is called a rheostat. We call it a rheostat, and this is what you could see in this paper right here in this diagram. You could see a rheostat there. I might be answering some questions as I'm giving you some background information. Okay, so what is the symbol? The symbol, every time you calculate resistance, you put ohm symbol. So if you found that your resistance was 3, so you say 3 ohms, just like that. Many mistakes that I observed when you are writing your test, you used to write like this. You put ohm you put the symbol for ohm in front of 3. No, that's not correct way of writing. So you put behind, just like that. So that's the SI unit for resistance. Now, so we've looked at those terminologies. Now I want to run through what some of the principles you should take note when you have components arranged in the series. So from mathematics, you've learned that series is actually just numbers that are following each other. So even in science, we have definitely some components connecting in the same arrangement where they are following each other. The other one comes after the other one, just like that. So we call them, they are arranged in the what? In the series arrangement. So series. So now when components of or appliances are arranged in series, what some of the principles should help you to calculate voltage, resistance, and current. So all we know that the relationship that defines between voltage, resistance, and current, we call it Ohm's. So that relationship, we call it Ohm's law. So now, what does Ohm's law say? So Ohm's law states that the current flowing through the wire, the current that is flowing through the wire, is direct proportion to the voltage and inversely proportion to the resistance. So when something is direct proportion in science, it means that something is increasing, another quantity is also increasing. Or we can illustrate this in this way. Imagine you have two people, okay, you tell them to run, okay, this one, another one just right there, okay, you tell them that run. So this one start running, another one also start running. The moment this one sees the other person, human 1, human 2 also increase the speed. Human 1 also see that the human 2 is running faster, also increases the speed. So these two, they are direct proportion to each other. This is because whenever someone sees the other one increasing the speed, the other one also increases the speed. That is similarly what happens. So when you increase current in the resistance, in the circuit, voltage also increase. So if you had the current 2 amps, you increase it maybe by 2 times, it becomes 4. And in the initial stage, you have voltage of 1, okay, 1 volts. You increase current by 2 times, even this one will increase by 2 times to become 2 volts. You increase current by 2 again, it becomes 8. Voltage will also increase, will become 4. So they are direct proportion to each other. That's the meaning. So Ohm's law gives us that. All right. So so Ohm's law mathematically can be written as, since we are saying current is direct proportion, so mathematically we can present that as direct proportion to voltage and inversely proportion to what? To resistance. So this is the formula for Ohm's law. And this formula, you can play with your mathematics. So if I want to make V as a subject of the formula, I can just write, play with some math there. So is equal to V over R, so over 1. So then I'll do cross multiplication there. So 1 times V, it's going to give me V, and I times current times resistance is going to give me IR. So you've also derived what? The second formula. You can also play with the same formula. If you are calculating, for example, resistance, you can just get the same formula. You write V is equal to current over R. So you want to remain with, or you want to make R as a subject of the formula. So you divide by current both sides. So this is gonna be, that current cancels with that, so we remain with R. So R is equal to voltage over current. So whichever formula among these three you can, if they can help you to calculate any of these. Okay, that's our formula 1. Or the other best way you can do this is actually you make a triangle. You make a triangle, you do like this. Okay, All right, so if you are calculating voltage, you can put your voltage up there, then yeah, you say current times what that. So meaning if you are calculating voltage, you cover V, meaning you are multiplying current times resistance. If you are calculating resistance, you cover resistance, and you divide voltage, you divide its voltage over current. All right, so then every time you are calculating current, you also cover current. It means you divide voltage over resistance. Simple as that. Okay, so in the exam, where we leave space for you to calculate there, show your work there. Mostly it's important for you to show calculations there. Don't expect that to give you marks if you are not showing your work. It means we assume that you are just copying, so you need to do that. All right, then what if now you want to find you want to calculate resistance that are connected in series. So when we have resistance connecting in the series, the formula we use is this. So total resistance is equal to resistor 1 plus resistor 2 plus resistor 3, depending on the amount of resistance that you have. So if we have this kind of wire having so resistance connected in that arrangement, which is a series arrangement, okay, so, and we imagine that this resistance, the first one resistor is reading as 2 ohms, 3 ohms, 4 ohms. So our total resistance in the circuit is going to be calculated as total resistance is equal to 2 plus 3 plus 4. So when you add that, it's going to give you what? So that gives us 5. It's going to give you 9 ohms. So that's your total resistance in the circuit. So that's how we calculate. So at your level, most we don't give you resistance in parallel. You find them in grade 12 there, where we'll teach you that. Okay, so that's how you handle resistance in the in the series. No matter number of resistors given, just add them to find the total resistance. All right, then Ohm's law we'll use many times we'll use the formula for Ohm's law. So let's get started with these now questions. Okay, so identify instrument L. Definitely instrument L is what is rheostat. Okay, so rheostat is an instrument used to vary resistance. So that's what rheostat do. So you can change the resistance. So this is the instrument used to measure variable resistance. All right, so we move on to the next question. What is the total number of cells in the battery? So there, how we count total number of cells, you just count the longer one and the shorter one. That's 1, another one, and that one, 2, that one, and that one, 3. So we have 3 cells in our circuit. So we have 3 cells. Okay, so that's how we count. So you just count the longer line, vertical line, and the small one, all of them. So that's a pair. So a pair of this, that's 1 battery. Okay, that's also 1 battery. 2, that one also 1 battery. So you shouldn't fail this question. It's too easy for you. Just count the pairs. Then B, how are the resistors M and N connected in the circuit? Like I told you, resistor M and N, they are following each other after one another. So these are connected in what? They are connected in what? In series. So the answer there was just to say they are connected in series. All right. Then we move on to the next question. Okay, so the next question says calculate the total resistance in the circuit. All right. So since we have nothing here, nothing is being read here, we haven't given the resistance for each of the resistor M and N. So what we are going to do, we are going to find the total resistance using what? Ohm's law. So Ohm's law says that voltage is equal to IR. Okay, so I'm calculating what? Voltage. So if we correct the data, you'll find that voltage given on the cells or battery is 6 volts. Okay, then current given reading on our ammeter there, our current is 2.0 amps. Then what are we looking for? We are looking for resistance. So we'll just take those variables and plug them into our formula. So voltage is equal to, let me repeat it. So 6 volts is equal to current, which is 2.0 times a resistance. So 2.0 times R is 2.0 R. So 2.0 R is equal to 6. So I want to remain with R. So you divide both sides by 2.0, both sides by 2.0. So that goes. So our resistance is equal to, so 2 into 3, it gives us what? 3 ohms. So our total resistance is what? Is 3 ohms. Okay, so we are done with the Roman numeral 1. So let me just remove these, just few of them. Okay, oops, it's going to complicate my things now. Okay, so then we go to Roman numeral 2. Calculate the resistance of resistor M. Since our total resistance from the circuit is 3, so we know that the formula for us to find this is total resistance is equal to, when they are connected in series, it's R1 plus R2. Okay, so we'll just take, we'll replace where there is total resistance, we'll put 3. So 3 is equal to 2 R1 plus 2R, we are going to have 2R. Okay, then you divide by 2 both sides. You want to remain with R, so it will give you 1.5 ohm. Now, since they have told you that, if you read on top, it says that resistor M and N are equal resistance. So if you find that one of the resistor is 1.5, so definitely even N is what? Is 1.5 resistor. So if you add these two, they have to give you the total number of resistance, which is 3 ohms. So resistor M, the value is 1.5, just like that. Then the question, okay, so the question, what would happen to the total resistance in the circuit if both the voltage and the current are doubled, is that resistance depends on the ratio of both voltage and current, or voltage to current. So even if we double these two variables, the resistance will stay the same because it depends on this. So whether you increase, the resistance will stay the same. And the reason to justify that answer, you say, even if voltage and current are doubled, the resistance does not change because the resistance depends on the ratio of the voltage to the current. Okay, so the answer to that question is that it will remain the same. The resistance will remain the same. All right, then let's move on to the next question. Let's also practice here. What is an electric current? So what you are required to say is just to define what is current is. So this is the flow of charge through the conducting wire. Simple as that. Then they also asked you voltage. What is voltage? So voltage is the energy converted per unit charge passing through a component. or is the amount of EMF supplied through what? Through the conducting wire. So there it was open, you can give either two there. Then name the device that is used to measure current. Definitely, as I was giving you introduction, I talked about this. It is called ammeter. Okay. Which number in the diagram shows the correct position of device used to measure voltage? So 1 is a correct number which shows the correct position of voltage. So every time you are measuring voltage, if you have components, let me illustrate here. If you have components connected, or maybe these are resistors connected like that, you always place your voltmeter in the parallel arrangement. So most of the time they ask you in the exam, what is the difference between instrument V and instrument A? So ammeter is always connected mostly in series, while voltmeter is connected in what? In parallel. So this is what you will see. So 1 is the correct position of pressing what? Voltmeter when you are measuring voltage at this component. So this means that this voltmeter will read the voltage, the amount of energy this component is using right here. So those are the key things you're supposed to say there. Okay, so 1, you put 1 there. Calculate the resistance of the light bulb when the switch is closed. So let's correct the data for C. So C, so resistance, so we have current given at the bulb is 3 amps. So current given is 3 amps. Then voltage given from the source, so voltage is 6 volts. So what are we looking for? Okay, so what are we looking for? We are looking for resistance. Okay, so yes, we are looking for resistance. So the question was supposed to be D. Okay, so resistance, so voltage is equal to 3. Let me be thorough so that no one can get confused. It's equal to IR. So I'll replace where there is V, I'll put 6. Where there is current, I'll put 3. And I'm looking for R. So I'll divide both sides. 3 that. So resistance is going to be 2 ohms. So that's our resistance. So our resistance is 2 ohms. That's the total resistance. Okay. Then apart from lighting, state other use of electricity in the local environment. This is a question where any student should pass, everyone, because we use electricity at home. So you say, apart from lighting, we use electricity for cooking, using cookers. We use electricity for cooling food in our refrigerators. So many aspects of use of electricity. Just think of anything that you use electricity for you to do what? To work. So that's what you will. Then let's practice the last question in this video. Okay. So as usual, the following diagram shows a battery connected to an ammeter and 2 bulbs in the electric circuit. So identify the part labeled U. So where is U? Definitely our U should be switch. That is a switch. So you just put your answer there. Labeled U is what? Is a switch. Just like that. Then how many cells are in the battery? So many times I've shown you how to count batteries, or cells. So that pair 1, that pair 2, that pair 3. So how many cells? 3 cells. Okay. What will be the current at part marked W in the circuit? So meaning they are asking you what could be the current here. And the principle is that when you have when you have the series arrangement, the current is the same at all points in the circuit. So the current that is passing through, it's the same 2.0 amps passing through W. That is the same also current that is passing through where? At 1 ohm resistor. So at V, I mean. So that is the same current. So those are the things you're supposed to recall there. Now let's move on. Calculate the voltage across V and W. Okay, so how we are going to handle this is that we correct the data for this problem. So current is the same, so it will be 2.0 amps. Then at V, what is the reading of our resistor there? Is actually resistance there is 1 ohm. Okay, what are we looking for? We are looking for voltage. So we write the formula: voltage is equal to IR. Okay, because the question has specified that you show your work, that's why I'm doing this. Equally, you, when you are doing this in your exam, you show how you calculated your how you solved your question. So voltage is the one I'm looking for. So V is equal to current 2, I'll replace. Where there is R, I'll put 1. So voltage, how much am I having? I'm having voltage of 2 volts passing through 1 ohm resistor. Okay, done, just like that. Then you go to the next question. I'm now calculating what? Voltage across what? Across W. Okay, so we'll just correct the data at W. So at W, our resistance is reading as 2 ohms. So resistance is 2 ohms. Then current, we know that it's the same, so 2.0 amps. We're looking for voltage, which we don't know. So you write the formula, then current multiplied by resistance. So we replace now. So where there's current, 2 as usual, times current, which is times resistance, which is 2. So what do you get? You get 4 volts. That's the correct answer here. Then you move on to E. Calculate the voltage value of one cell in your show you're working. So they want us to calculate the value of one cell, and this is so easy. Remember in class I taught you that if they have given you the total resistance, I mean the total voltage at the battery, if for example these batteries are giving us 9 volts, then each battery, we can find how much voltage each cell is giving by dividing by the number of cells. So in this one we have 3 cells, so if we divide it just like that, divide by 3, what are we going to have? We are going to have that each cell will give us what? A voltage of 3. Okay, 3 volts. So that's similarly what we are going to do here. Now what we are going to do here, we are going to find the value. Since we found each of these, so we are going to find the total voltage that we can have there, and we are just going to add. So when we add the voltage at each resistor, then we find the total and divide by the number of cells that we have. Okay, to do this, so you can handle it in this way. Okay, so you can say total voltage, you add voltage that you calculated on the first resistor plus voltage you've calculated on the second resistor. So you add 2 and 4. So 2 plus 4, what do you get? To give you 6 volts. So this is the total voltage in the circuit. So now how many batteries do we have? We have 3. So you get 6 divided by 3, and it will give you that each cell was emitting what? 2 volts. That's one way of handling this question. The other way, you find the total resistance using Ohm's law formula. So you know Ohm's law formula is IR. Okay? So the total resistance, how are we going to find it? We'll add. We know how to find total. So we'll add that 1 plus 2. So our total resistance here, so if I write the data here, so total resistance is equal to 1 plus current 2. So 1 plus 2, this gives you what? Gives you 3 ohms. Okay, current is the same, so current is equal to 2.0. So you will replace these two values in the formula. So voltage is equal to 2 times 3. What do you get? You get what? 6 volts. Again, since this is the total voltage across the circuit, so the voltage of each cell is 6 divided by 3 cells, and this is gonna be 2 volts. Same. So this is how you can handle this question. So today, this is how far we can go revising electricity. If you have touched all the important things that you need to remember, which you might have missed in class, if those who understood, that's a plus for you. So you just go through this. All right, I'm open to the questions before exam. Please feel free, plug into my office and we discuss, come in groups so that we handle these questions. Thank you.